So once again, a very good evening, everyone. So this is basically the session number 13 of 6 days online FDP on remote sensing and GIS. And for the next session, we have with us our esteemed speaker, Dr. Prakhar Misra, Assistant Professor, Department of Civil Engineering, Indian Institute of Technology, Roorkee. Before inviting him for the session, I would like to give a brief introduction about our esteemed speaker. Dr. Prakhar Misra is currently working as assistant professor in the Department of Civil Engineering with a specialization geomatics engineering in IIT Roorkee. His area of interest includes remote sensing, GIS applications, and techniques for human environment system, multimodal deep learning for optical and SAR, air quality and GSE emissions, environmental impacts, One Health, land use change, and urbanization. Sir has completed his BTech plus MTech dual degree in civil engineering from IIT Kanpur and has obtained PhD in engineering from the University of Tokyo, Japan. Sir is also Sir has also authored so many. Sorry, Sir has so far 18 international journals in his credit, and currently some of the PhD students are also working under him. Sir has also the paper publications in conferences such as national as well as international. It is our privilege to have you, sir, for this platform. And without wasting the time, I would like to invite you and hand over the sessions to you.
Thank you, Professor Ankur, for your very nice introduction. So I'll just share my screen and let me know if it is visible to everyone. I hope my screen is visible now.
Yes, sir.
Okay, perfect. And I also have this red colored laser pointer. And apart from this screen, I will be using this this Chrome browser also for
Okay.
some of the display. So I
Right.
just want to also confirm whether the fonts are visible on this Chrome browser or not.
Yes, sir. It is visible. No problem.
Perfect. Okay. All right. So welcome. And I think this is the last day of your training. So I would like to, even though it's a workshop, but still I would like to keep things more engaging so that we can make the most of this time, about 1.5 hours that we have with us until 6:30. And I'll try to wrap up within 1 hour so that we can keep the rest of the time for discussion and maybe some question answers. And the agenda for today, as part of this training, is why do we need cloud-based processing? So we have been using some softwares. All of us have some experience in downloading data. So why should we now move to this new kind of processing? What is the merit in doing this? And after that, we will learn about this cloud-based processing platform, which is known as Google Earth Engine. And we'll see some hands-on demonstration. So of course, everyone knows about Google Earth. Google Earth is where you can see those high resolution satellite imagery. We can also have the time lapse. We can go back in history and check out those high resolution imagery. But the Google Earth software that we use on our laptop or in our computer is just useful for very simple analysis. It's just useful for looking at the image or maybe taking some very easy measurement. When it comes to remote sensing, we are not able to do that in Google Earth software that we currently have. When it comes to remote sensing, what we actually do is we either download the data from some platform or we already have the data uh, from some previous researcher and then we process it on using some software like ArcGIS or QGIS. But there are some limitations to that, and based on those limitations is where this Google Earth Engine comes in. So these are the scripts or some programs that I will be working on for today's workshop. I don't think we have time for the classification script. Script is just another word for program. So I don't think I have time for classification script today, but I will still be sharing this presentation with Professor Ankur. So I hope Professor Ankur can then share it with all the participants who are attending today. But but my core focus will be to walk through the basics, very basics of Google Earth Engine, which will happen through image display and calculation of NDVI. Okay. So let's look at the motivation behind use of or rise of Google Earth Engine. In fact, first is I think everyone knows this website, very famous website, USGS Earth Explorer. In this website, we can download a lot of the data which is captured by NASA on behalf of USGS, especially the Landsat data, which is very popular, very famous, and very long-running dataset series. So in this, what we have to do is we have to provide either we can provide the exact address, or we can provide the path and row of the Landsat, or we can also give some kind of uh, 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 coordinate or shape files. We can give those shape files also over here. So based on this, then it can search. Not only the area, we also need to provide some date range also. Yes, we need to provide some date range that from which start date to which end date we want to search for the image. We need to provide the area over which want to search for the image. And also we need to then select which satellite sensor we want to get the image from. So based on three basic criteria, then it can shortlist those images which are available. Then when the images show up, we can check which images have cloud, which don't have cloud, uh, whether those image match our criteria. And if they do, then we can download those images. Okay. Then this process is clear to everyone. Then can you think of the problems that happen because of this process? One of the major problems that happens because of this is that first of all, we have to download the data set. Now, sitting in 2025, when we have almost everything happening in the cloud, downloading the data set does not seem very futuristic or does not seem very contemporary anymore, especially because remote sensing data sets are getting huge and huge. Second is uh, not only a single image, one might want to work on a time series of image. So a single image may not be satisfying the needs of the research. Second is, let's say you download the data. It may happen that you download the data, 5 or 6 files, and then you realize, okay, the area was slightly different, or maybe it has cloud. So downloading incorrect data set also happens. Then once you download all this data, third problem is how do you process this data with use of all these machine learning based and AI based algorithms. We cannot just process this data on our very simple laptop or our desktop. Processing also becomes a bottleneck. Another bottleneck is storage. Remote sensing data, as I mentioned, can very quickly take up terabytes of storage. So storage, should it be in hard disk or should it be in solid state? Because solid state is faster, but solid state is much more expensive. That also becomes problem. And finally, the biggest problem is how do you share that data set? Let's say you have done all the processing, you have downloaded and done the processing and everything. Now you want to share this data set, share the results that you have. How do we share that with other people? That also becomes a big problem. You can also imagine a situation where you want to share the data set with some of the agencies or government agencies you are working with or some of the other stakeholders. And it has been found that the more we share our data set, the more likely it is that your research becomes useful for society. If we do a lot of research or if we do a lot of work, but if it is not shared within anyone, then that results just tend to stay within those research paper only. They do not become very applicable for the society. Then at the same time, the another concept has been emerging, which is of analysis ready data cube. So what is analysis ready data cube? Sorry, I have a bad throat, so please pardon me if I cough. So analysis, so there are two terms here, analysis ready and data cube. So data cube means that instead of working on just a single image, now we will have cube or you have time series of images. So ultimately, we will have this cube kind of setup. So here you can see this cube. This is one image from 18 Feb, another image from 22 March, another from 7 April or 10 June, all over a same lake. This is like a cube which is emerging. And analysis ready is that how can we make a remote sensing data set be available in such a form that even if someone does not have very deep understanding of how the remote sensing data was acquired, what is the difference between surface reflectance and top of the atmosphere, what is the difference between different collection or tier type, still people may be able to use this data if they know what they want to use the data for. So that is the concept of analysis ready. So overall, the concept is analysis ready data cube. So this is the concept that has been emerging, and several agencies around the world, NASA or JAXA or ISRO, they're also working very actively towards analysis ready data cube. So many of the space agencies around the world have the analysis ready data cube. So basically, if you select some particular types of data sets, then you can already get ready-made product out of those data sets. For example, as I work on air pollution primarily, so I'll give you some examples from there. For example, satellite cannot directly monitor PM2.5, which is very harmful pollutant for human health. But satellite can monitor something else called aerosol optical depth, which is also known as AOD. But from the AOD, some researchers have derived PM2.5. So these daily images of PM2.5 now are being shared as analysis ready data cube. So analysis ready data cube again is getting more and important. I'll just give you one more example. If you see, for example, this particular pixel, which is called as Brooks Island over here, so you can see we can measure the spectral property, or we can measure what is happening on this particular pixel on several dates. Now we can calculate its time series also. And we can calculate time series, then we can find out whether the trend of the spectral property is increasing or decreasing. And what is going to, we can also use this to forecast what is going to happen. But for all of that to happen, we need the analysis ready data cube, or we need a data cube. This is where Google Earth Engine comes in. It is a cloud-based platform for planetary scale Earth science data and analysis. So cloud-based means all the calculations will happen in the cloud. In the cloud, similar to how we use Google Drive or we use Dropbox, similar to that, all the calculations will happen in the servers, in the computers which are hosted on the servers of Google Earth, Google. So even if the data sets are huge, the calculations will still be very fast because they are performed on Google's server side. We need to fill a quick application, and it works with, if you already have a Gmail account, then you can get going. Usually, what I've seen is that some exposure to programming is preferable, that for getting started. But even if programming exposure is not available, with the help of recent tools like ChatGPT, we can still use Google Earth Engine. Now, I will show you some examples. Even if someone does not have background of programming or does not have much understanding of Google Earth Engine, still with tutorials and ChatGPT, we can write some basic program that can help uh, bring some confidence into using Google Earth Engine. Also, Google is not the only company which has its own cloud processing platform. There is also Amazon, Sentinel, and Descartes Lab. Okay, I think someone is using these annotation tools. So on my screen, I see this red and yellow markers. So Professor Ankur, can you get rid of these? This yellow marker and red marker. I'm not sure if it is visible to you. Yes, someone is has drawn a blue marker also.
Sir, 1 minute.
Yeah. So this slide just shows what has been dominant application areas of remote sensing where Google Earth Engine has been used very much. So most of the users of Google Earth Engine are researchers working with forestry, land use, land cover, wetland hydrology, and agriculture, as well as disaster. These are the uh, major streams in which Google Earth Engine has been used. This image is slightly old, and now the number of papers which using Google Earth Engine is into tens of thousands. So it has been taken up very rapidly by the global as well as Indian remote sensing community. Some of the examples, early examples of usage of Google Earth Engine are mapping rice planting area for whole Northeastern Asia. Before Google Earth Engine, most of the studies only used would do this kind of rice planting area study for very small localized, maybe just the area of interest or the region of interest would be limited to just single Landsat image. But with this kind of platform, now researchers were able to do study over whole Northeastern Asia. Similarly, this very one of the earliest study was able to detect industrial oil plantation in all of Southeast Asia, in Malaysia, Indonesia, and Thailand. So, because of Google Earth Engine, this was made possible. Other thing was also earlier when such studied were for detecting the oil palm plantation using Landsats were attempted. The biggest challenge was that in equatorial areas like Malaysia or Indonesia, they're usually covered by clouds. So because of such cloud coverage, it is not always possible to sort out which Landsat images are going to be useful, and maybe image of one area is available on particular date, but the neighboring area is not available on particular date. So it was a very complex affair earlier. But with the help of Google Earth Engine, creating a very smooth mosaic over whole of Southeast Asia became possible, and this kind of study was done. Then this is the other very important study which came in initial stages was detecting the boundaries of urban areas. Again, I think a lot of us have worked on urban areas or urbanization, but most of our studies usually are just limited to one or two cities or three cities. But why should that be the case? Why not we analyze the whole India? And Google Earth Engine again is very useful for a large country like ours, where we need several images to cover the whole country and be able to also compare like what is happening in Delhi may be different from what is happening in Chennai, or what is happening in Delhi may again be different from what is happening in some tier 3 city in South India. So only if we are able to analyze the whole Indian landmass in the same go, only then we are able to understand these urban dynamics much better, which can only be possible if we have a setup where we don't have to download the images, where in the cloud itself all the images are present, and with those images we can process the data in the cloud itself. These are some past examples that have come out. Now I will show you some of the apps that have been made on top of Google Earth Engine. So Google Earth Engine not only allows you to do the analysis, but also allows you to prepare or visualize those analysis and then share them with others, as I just mentioned in one of the earlier slides. So this slide is showing the nitrogen dioxide before and after the lockdown. So we all have seen the lockdown, and then in 2020 we saw that when the lockdowns were there, there were a lot of studies or reports that because of the lockdown, human activity has been suspended, and because the human activity is suspended, then pollution has also decreased. And this was observed in the form of decreasing concentration of tropospheric nitrogen dioxide, which can be retrieved from satellite, especially the Sentinel-5 5P. Then I will show you this. I'll show you this site. I just click over here. Yes, then this should open. Okay. In this, so this is just a very simple web display that I created at that time, around 5 years ago. So we can compare. On the left side, we can have some image before the lockdown. So I will just select maybe image of 2019, last week of March. And on the right side, we can have an image which was from the lockdown. So we can have image from 2020, last week of March, which is when the lockdown started. So 2020 March, week 4. And on the left side, we have 2019 March, week 4. we can compare the corresponding weeks of 2019 and 2020. Let's see what is the difference. So 2019 is left side and right side is 2020. So we can see that there are these plumes of nitrogen dioxide which are present. We can see that they have slightly reddish or pinkish color on the left side, but after the lockdown, these plumes were all absent because of decline of human activity. Then let's see one more example. Then on the left side, this is somewhere near, I think, southern Bihar. We see this very intense nitrogen dioxide uh, in in the pre-COVID time. Then after COVID time also, we see that nitrogen dioxide is very high. And the reason for this is coal mining was taking place over here, and these were classified as essential services, coal mining as well as thermal power plant. So because these are essential services, no decrease in nitrogen dioxide was seen over here. More sharp example can be seen in China. In China, on the left side again, we will see the image prior to lockdown. And when I will move the slider to the left side, it's during the lockdown. Left, we see a lot of pollutant are here. On the right side, we see pollutants have decreased. This is one very simple app that I created using Google Earth Engine, and you can also create that. Okay. Then I'll show you now slightly more complicated apps which have been created by some other researchers. So this app again here shows you an explorer for the Tropomi data. Tropomi is Sentinel-5 satellite. So after clicking that, we see this kind of setup. On the left side, we have option to select different types of pollutant, nitrogen dioxide, carbon monoxide, and so on. Again, I will select carbon dioxide, then which variety of the pollutant algorithm we want, near real time or offline. Let's say near real time. And again, we can select these dates from which to which date we want to check the, the comparison and the trend of the pollutant. So let's say I select here 2018, July. This is just a random date. And now what it will do is it will show the July 2018 on the left side and January 2020 on the right side. And on the bottom, it will also generate the time series between these two dates. And the time series is being generated for this particular point, which is marked by this pinhead. So the time series will be generated over here. So all these examples are there, so you can check them later also. So time series like this, as shown in the slide, will be generated. This allows us to study the rate of change of pollution from the satellite data very quickly. Earlier, one would have to download. Let's say I'm working on, let's say working on Roorkee or maybe Lucknow today, and tomorrow I start working on Gujarat. Then I will have to again download data for 10 years from Gujarat, which is not very efficient way to do. So with this, all the data is already present in the cloud. And by writing some very easy programs, we can access those data, process them in the cloud, and we can analyze the time series trends. Okay, let's see some uh, more examples. Then this is a study which was published in Nature, which is showing the Earth's surface water change over the past 30 years. So whether the surface water has increased or decreased. So if the water has increased, then it will show up in the in blue color, and if it has decreased, then it will show up in green color. This was made possible by studying the Landsat image over 30 years, and again analyzing 30 years of Landsat image for the whole world is not easy task. if someone wants to do this kind of analysis in their own laptop or own computer, it will take more than 3 or 4 years. But with this cloud processing platform, it was being done in a matter of few days. So what we see is that in India, we see that most of the rivers show up in green. So green, as I mentioned, was where water is shrinking, and blue is where water is expanding. We see most of the places are showing up in green. Some are also showing up in blue, for example, over here, which suggests the change of the channel of the river. So green means that river maybe earlier used to flow from here, and blue means now the river's channel has become on this side. Not only rivers, it is very useful for analyzing the glacial lakes or lakes in mountain Asia, or also known as the Himalayas. So in the Himalayas, what we can see is, for example, here and here, we can see that in all these lakes, blue is increasing. Blue is increasing that in these lakes, water is increasing, which is actually not a good thing because these lakes are always frozen. And because of the climate change, now the lakes have started melting. Since the lakes are melting, they are the ice is getting converted into water, which will then get converted into maybe more runoff, and then can also create potentially more floods. So overall, this is not a good news. We can see that all these lakes, you can see that more and water is coming up as shown in blue color. All these lakes in Tibet. Similarly, all the lakes in Uttarakhand also, they are showing the uh, increase in water. If we have been following landslide research, then in past few years, there have been landslides in Uttarakhand and also in Sikkim due to something called GLOF. GLOF means Glacial Lake Outburst Flood. So sometimes what happens, these lakes are situated very high on top of a mountain. And when, uh, because of a melting of a glacier, maybe on top of that mountain, more water comes into that lake, then the natural dam of that lake sometimes breaks off. Because of that break off, it causes very huge amount of flood downstream, which also causes landslide and lot of cascading disasters. So this kind of study is possible only if we are able to analyze a large amount of historical data. Then I will show you some interesting analysis from the North Korea-South Korea border. So if you look at this particular river over here, you can see that this particular river is water is coming, but suddenly you can see water is coming, and but suddenly the water stops over here. Can you try to guess why this is happening? What is happening over here? The river is there, but suddenly the water just stopped. So the reason for that is North Korea has built a dam over here. If we just zoom in, we can see that there is a dam over here which has been built by North Korea, and this is the reservoir of that dam. So whenever North Korea wants to create some problem for South Korea, then without warning, it releases a lot of water to this dam, which creates also floods in those villages in South Korea. Because of that, this is a very constant cause of confrontation between North and South Korea. So we can also see such uh, geopolitical dynamics being played out through remote sensing data when we are able to analyze these long-running remote sensing data set. This is another analysis done by University of Maryland, and this is the map of global forest change map. So this kind of analysis, as was mentioned by the authors, would have taken single computer 15 years to perform, but it was completed in just a matter of days using Google Earth Engine. So this is the link to that analysis, and let's have a look at that analysis. So in this analysis, they have given, so this is a global analysis done using Landsat. Landsat, every pixel is 30 meters. So it's a very high resolution, very huge data set for a very long time span from 2000 to 2019. Earlier, it was just 15 years, but now they have added some more analysis. It's a almost 20-year analysis now. So we can see the forest cover loss. So let me just put that over here, forest cover loss. So the places where forest cover loss is taking place now shows up in red color. So we can very easily identify a lot of places where forest cover loss is taking place. All these places are also associated with a lot of fires. We can see this loss is taking place in Canada. It has a lot of fires. There's this uh, west coast of US, lot of fires. There's again this portion of the Australia, which is usually associated with a lot of fires. Also Russia, lot of fires, and also Southeast Asia, again, lot of fires. We can also see whether any efforts have been done to increase the forest cover. So that shows up in blue. So very few places are there. But interesting thing is that this Indonesia and this Malaysia, Borneo, this area, we see blue is showing up, which means forest gain is happening. At the same time, red is also here. That means forest loss is happening. So can you guess why we have both forest loss as well as forest gain at the same in the same place in the same duration? Is this some kind of error, or this can be explained by something, by some phenomena? So I'll give you the reason for this. The reason is this place had lot of natural forests, but those natural forests were actually cut down, and they were replaced by oil palm. For oil palm, as you know, is very important for making dalda. Oil palm is also used in making of soap or shampoo. So all these natural forests are being cut down in Southeast Asia, and they are being replaced by oil palm plantation. So we see both loss as well as gain and in the same place. This is one more example about the trend of nighttime light. So I will not go to the specific example again, but again, by mapping the nighttime light, we can study the socioeconomic behavior of different places. So red is those places where nighttime light has been increasing. So you can see that in India, especially India and China, nighttime light has increased from 1992, since when this data began. A lot of nighttime light has increased. Green means those places where nighttime light has remained same. We see that in UK and in Western Europe, nighttime light has remained same. And red means those places where nighttime light has decreased. So this is very surprising, because red can mean more economic prosperity with time, or conversion of maybe some underdeveloped country to developing country status. Green can possibly mean that country is already developed. But why will some country have blue? That means why will in some country the development status will go down? So if you look at these places, these are places which are associated with a lot of conflict areas. These are East Europe, also places like Syria or Israel, and those places in West Asia, which have a lot of conflict. And because of conflict, many people tend to migrate out of these places. And once they migrate, the nighttime light decreases. Then there are these kind of analysis, which is known as breathing Earth. So again, we can analyze how the Earth, Earth's surface cover changes throughout the year. This is showing the northern hemisphere, and we can see how in winter it has snow cover. Then in after that, spring comes, then summer comes, everything becomes green, and then in the autumn, trees start shedding their leaf. In the winter again, or trees have lost the leaf and snow comes. This is very important for studying the carbon cycle, or also studying the greenhouse gas cycle, greenhouse gas emission from the earth, especially from the biomass. So for greenhouse gas study, this kind of data is very, very useful. So this is not animation, this is actual remote sensing images which are collected over the course of a year, and then they are uh, mapped using Google Earth Engine. We can also study time lapse. So here it is showing the change in the river morphology over a period of 20 years. Uh, this was analyzed by a researcher group at UC Berkeley, and they plotted the age of the sediments, basically, or the last time when the river was seen in a particular spot. So red means that river passed over this pixel or this region several years ago, and blue means that the river passed over this region very recently. Then based on this, again, analysis was done using Google Earth Engine. They have created something called global surface water animation. So let's look at this. Uh, so global surface water gives you the most recent year of water occurrence. So this is showing you some location in South America. And for a river, it is showing us what is the most recent year of water occurrence. So if it is yellow, that means water was there in 1984. And if it is bluish, then that means water was there in recent years, like 2018. Then we can also plot animation of that. So this rectangle, you can see the animation of this region is showing up on the right side. Let's try to create something similar for also uh, uh, Professor Ankur, is my voice audible?
Yes, sir. Perfectly.
Okay, perfect. So I will show you this around Bihar area because we see a lot of flood happening over here, especially on account of the Kosi River. So I will show you most recent year of water occurrence in the Kosi River in Bihar area, and this is a very it has a lot of alluvial sediments. By the way, I'm not sure if this is Kosi River, but I know this is a river which is changing its course every year. So I'm just showing this as an example. So I will just select this as a region, and then you can see on the right side it is showing up as generating thumbnail. Very soon the thumbnail will be generated for this region, and we can see how it is changing the course. Then this kind of data is very important for uh, not only government agencies but also when planning of bridges take place, or planning of railway bridge, or planning of highway bridge take place. Especially for such planning or the feasibility study, we need to know which all areas are going to be covered by water. If let's say heavy rainfall happens, or in the past, which areas have been covered by water. Also, we need to know how the river is going to change its course in the future. So, especially all those areas should be taken into account when we are planning for bridge or railway line. This is one example regarding that. These are some other examples again for deforestation and for urban growth in Hyderabad. As you can see, the most of the growth was over here. Yes, most of the growth was over here, but then when it became very popular as IT city, then growth started happening outwards. Similarly, in Bangalore, we often hear that there are floods happening in Bangalore, and the reason for that is you can see this was actually a floodplain for some river, and Bangalore was also known as city of lakes. All those lakes were lying in a floodplain of some river. But slowly and slowly, these floodplains and these water bodies were claimed by real estate. They drained out the water. First of all, they made sure that water pollution is happening. Then they drained out the water. Then they built some real estate projects. And now, when these projects are experience flood, then they complain that flood is happening. But actually, these water bodies should have remained untouched and should have been preserved. So you can also create your own time lapse using these sites. So the programs, the scripts that I have shared are for the objective of classification. So we have the remote sensing image on the left, then we can do classification. And most of that will be done by Landsat. So first of all, I will introduce you to the concept of image collection in Google Earth Engine. So even before that, I'll show you how Google Earth Engine code editor looks like. So once you open Google Earth Engine code editor, which can be opened by this link, you will see on the left side uh, is where all the programs are stored. In the center, which is known as the editor, this is where the programs are written. On the right side, if there are any errors or if there are any numerical output, we can write it on the right side. And in the bottom is where we can see the maps, which are all displayed. Whatever results we have, they will be displayed over here. Then we also have the option to make shape files. Either we can make a point shape file or a linear shape file or polygon shape file. And then we can zoom in, zoom out. So by clicking on this new, once we click on this new, then this new empty script will open. Then we can start writing our short program. Then click on run, and then the output of that will be shown over here. So let's see. So the link to that is code.earthengine.google.com. No need to follow about this right now because I will be sharing all the scripts with you anyways. Very simple thing. Let's see. For example, I will write variable A is equal to 5, variable B is, and this is using JavaScript. But even if you don't have idea of JavaScript, but you know some other programming language, you can easily convert from one programming language to another using ChatGPT. Or even if you don't have very clear idea about the programming language, you can just write your task and then give it to ChatGPT. Then it will give you some output. You can try it out, and that is how slowly you can start to gain more understanding. So I'm writing variable 6 is equal to 6, b is equal to 6. Variable a is equal to 5 and semicolon, variable b is equal to 6, semicolon. Then I will write print a plus b. If I click run now, which is over here, then I will get the output over here. So output is 11, right? So this is how it works like a very simple program that we know how to write some programming languages. Then on the left side are some programs, very easy scripts that have been written. I will be using some of the script, and I've shared those scripts with you earlier. What else? If you want to understand more about some command, for example, this print command, right? So on the left side, there's also option of docs, which is documentation. I can just write print, and then I can check, okay, print, does it have any print here? Internal, be over here. Maybe it does not have because print is such a common command. I think they've not created for that. But for example, there's uh, there's a function called feature collection. Then if I write feature collection, then it can give me what feature collection means. I can click on that, then it can give us what is the meaning of feature collection, how to use this command, what arguments it will take, and what will be the return of this function. So basically, it can this serves as a very short kind of ready to look dictionary where you can just search for the function, then it can give us some its definition, how to use that function. We can also upload our own shape files or data. Let's say you have collected some ground truth by GPS or something, then you can click on assets, you can click new, and you can upload. Either you can upload your shape file or you can also upload image data. Let's say you have collected data from drone and you want to analyze data from the drone along with satellite data. Then you can upload data from the drone and you can analyze that with the satellite data which is already present. Okay, so then let me first talk about the satellite data which is present. So all the satellite or all the data which is stored in Google Earth Engine can be found through Google Earth Engine catalog. Instead of writing Google Earth Engine, you can also write GEE, GEE, Google Earth Engine, and you can search catalog, catalog. Then we can see the option of Earth Engine data catalog. So once uh, this Earth Engine data catalog opens up, we can either check all the data sets, we can browse them by tags. We can also check some of the most popular data sets like Landsat, MODIS, Sentinel, and how to use them. So let's see view all data sets. I've clicked, I'm trying to see what all data are present in Earth Engine data catalog. So it has a lot of data sets like Canada annual crop inventory. It has some examples of digital elevation model from Netherlands. We just go down. It has population density map. It has land cover map, water mass, methane, carbon monoxide, and many more data sets. I can also browse the data by tags. If I click on browse by tag, then it will give us, it will tell about the data not only on the basis of the information, but also on the kind of processing that has been done to make it analysis ready. For example, 16-day data. These are the data in which data has been averaged over a period of 16 days to get rid of cloud effects. This is common when we want to study vegetation trend, for example. A lot of MODIS data has been averaged over 16 days. So this is a tag, kind of hashtag by which all these data sets are shown over here. So I can also just, if I want to study, let's say, urban heat island effect, I can just write land surface, land, yeah, land surface, for example, over here. It is showing us land surface temperature. So there are three types of land surface temperature from this Japanese satellite GCOM-C present over here. Or I can also just write temperature. Then it will give us surface temperature. Surface temperature is same thing as land surface temperature, and these are the data sets already calculated, and these are analysis ready. So you don't need to calculate the temperature once again by yourself. So these are those data set from MODIS. Then, because MODIS was also affected by cloud, then some researchers have made algorithms to fill the cloudy days. So this is the data set created by Oxford about uh, so in that they have filled the gaps in the data set, which is happening because of cloud using some algorithm, and then they have shared their own value-added data sets. This is how data sets are present over here. Then let's look at Landsat. So Landsat, it has all the data from Landsat 1 to 5, 7, 8, 9. These are the data sets regarding Landsat which are present inside. MODIS is also present. In past few years, Sentinel has become very more and more useful. It has SAR, synthetic aperture radar data, as well as multispectral data, which is Sentinel-2, has multispectral data similar to Landsat, but at 10-meter resolution. It also has Sentinel-5 and Sentinel-3 datasets. So today I will be showing you a quick example using the Landsat example. So let's go for the Landsat 8 data. So we can click on the Landsat 8 over here. Just to remind where we are right now, what I did was I just searched GEE catalog, then it opened up Earth Engine data catalog. Then I clicked on Landsat, then I opened Landsat 8, and inside that we have three types of data. We have raw images, top of atmosphere, and surface reflectance. Usually our interest is to analyze the surface. So unless your interest is to go for the analyze the atmosphere, we should always select the surface reflectance. So in surface reflectance, there is tier 1 and tier 2. Tier 1 is a bit more high quality data sets compared to tier 2, so we'll go for tier 1. Then every data set has its own unique identifier like this. Similar to how we have our roll number or our house has address or we have Aadhaar card. Similar to that, every remote sensing data set in Google Earth Engine has its own identifier. Identifier for this USGS Landsat 8 data is Landsat slash LC08 slash election 2, so C02 T1 underscore L2. You can also check identifier of any other data also. So let's say GEE catalog once again. Let's say at this time I'm searching for, let's say something related with, again, NDVI, let's say. I'll just try NDVI. So MODIS has these vegetation indices, and here we can see its identifier is MODIS/061 mod 13A2. Now the role of this identifier is that using this snippet is how we are going to import this data into our program. I'll show you what that means just after a while. First, let's see the description of this data. This is Landsat 8. First of all, if we click on band, then it will tell us that resolution of this data is 30 meter. What are the bands which are present? It has B1 from B1 to B7 bands. So it has this blue, green, red, near infrared, shortwave infrared 1 and 2. These bands are present. Also, it has aerosol band. Then it also has some band for the surface temperature. So this is band 10. Band 10 is surface temperature, atmospheric transmittance, emissivity, and such some more bands are present over here. If you are already working with Landsat 8, then you must be aware that these bands are present in Landsat 8. Apart from that, image properties are also there. The band data set is available at every pixel. So for every pixel, the blue, green, red values will be different. Image properties are only available for whole image. So whole image will have the same property. Okay. Then regarding every data, they also provide some sample code regarding how to use that data set. For example, if they just mention the data set without providing the sample code, it often becomes difficult how to use the data set. Some basic code is always provided for each of these data sets. So we can look at this code and I will run this code and then also interpret what is the meaning of each line in this code. First of all, they have created this variable called dataset. So var dataset, and they have written here ee.image collection landsat lc08 c02 t1 underscore l2. So have you encountered this before? Yes, we encountered this just over here. This is the unique identifier of this particular data, Landsat 8 data. Okay, then this is, so we are actually saying that in this particular variable, we want to store the whole image collection. But in reality, we don't need the whole image collection of Landsat 8. If we just write this, then whole data of Landsat 8 will be called from this program. But we don't need that. Maybe we are more concerned about some specific date period, or some specific area of interest, similar to how we specify this in also in the USGS. So instead of selecting the whole image or whole collection of image, we also filter this image collection by our dates which we are interested in. So in this case, the example is showing images between 1st of May to 1st of June. Then out of that, okay, now we have selected the image collection that we want to use Landsat 8 data. We also selected that we want to filter our this whole image collection only from 1st May to 1st June. Okay, this is also decided. But then you notice that this Landsat 8 has so many bands. Band 1 to band 7, aerosol, 8RAN, and so many things. Maybe we don't need all of these. In usual case, let's say we just want to visualize red, green, blue, or we only want to create a false color composite. Uh, let's say we want to add near infrared also, or we want to calculate NDVI, then we need just few bands, not all the bands. So they've created a small function called apply scale factors. And first, what they have done is from the image, they will just select all the bands which start from like this SR underscore B. Dot is a wild character, dot and star. Dot means only one, any character can come in. It can be a number or alphabet. And star means any length of character can come in. So they want to select all those bands which start as SR underscore B. So SR underscore B, we can see that these bands don't start as SR underscore B, but these bands all start as SR underscore B. Only these first 7 bands, all these bands will be selected. Then all those bands will be multiplied by this particular scale factor, and this amount of numbers will be subtracted so that we can convert from the digital number to surface reflectance. As we know in remote sensing, all the images are digital numbers first, but uh, if we want to measure the physical property of the object, we have to convert the digital number to surface reflectance. So using this equation, these parameters are already provided. These parameters change depending on the satellite. For Landsat 8, these are the parameters. Similarly, thermal band can be selected as image.select st underscore b dot star. So all the bands which start with st underscore b followed by any number of characters, we will select. St underscore b, there is only one band, so it will be selected. And this kind of scaling factor will be applied. Then these bands will be added. So all these processes are happening inside the function called apply scale factor. This is a function similar to how we have function in other programming language. And the Landsat 8 data we had stored in the variable called dataset. On the variable called dataset, we will apply the function called apply scale factors, which means in the dataset which had all the band with digital number, now what will happen after applying the apply scale factor function is that only these sorts of band will be selected and they will be scaled by this particular equation. Then this is again stored in the variable dataset. Finally, we have the visualization parameters. Visualization parameters, we can specify which bands we want to visualize. So in this case, we want to visualize band B4, B3, and B2, which we know are bands red, green, and blue. So B4 is red, B3 is green, B2 is blue. So we want to visualize these bands. We want to adjust the contrast setting from 0 to 0.3. And when the data opens up, we want our screen, our map to be centered on this particular latitude, longitude, and latitude. They've given the longitude and latitude over here. And it will be shown in our map with the name of True Color 432. So with this explanation, let's now open this link. So open in code editor. I click on this link. So now this link is opened, and now I click run over here. Now this is showing some location in US. Why US? Because this is how map.setCenter was done. Okay, and on the bottom is the image. Here you can see this image. This is the image taken between these particular dates, 2021, May and June, over this location. We can change it actually. We can also select, let's say, some image over Gorakhpur. So where is Gorakhpur? Yeah. First of all, what we can do is we can turn off this layer. Okay. Then first of all, we have this button called inspector. We select the inspector, click on that. Then we click on Gorakhpur. First, when we click on Gorakhpur, immediately we'll get the longitude and latitude. So we can copy that longitude and latitude. We can paste it over here. We paste the longitude and latitude and click run. Now it will give us the image over Gorakhpur, which is between these two dates. So we can now see Gorakhpur between these two dates. We can also change the date here. Let's say we want to see more recent image from 2024. We can change the date also. And again, click run. We can again compare how it is happening in 2024 versus 2021. Then this number 8, this means what is the default zoom you want the map to open. So if it is 8, then I think it will be a bit far. And if it is higher number, then it is smaller number, it is close. Yeah, I think so. Let's try number 5. Oh, actually, small means we are very far, and large number means you are very zoomed in. So if I write 12 over here, then it's very zoomed in over Gorakhpur. Okay, so this is how we have just seen how to load Landsat image uh, for particular location or a particular date range over using Google Earth Engine. Then there's some more settings. We have layer. So layer we can turn on and off. We have some settings inside the layer also, by which we can control the visualization parameters. Let's say I want the image to improve the contrast, so I can just make it more dark also. Sorry, more dark, yes. 0 to 0.4, and then apply. It's dark. If the image is already appearing dark and you want to make it lighter, you can decrease this. So it is similar to how we do histogram equalization. So this is the thing. We can turn off these layers. We can also turn on a satellite base map layer. This is the same layer that you can see when you use Google Earth. Now we have the slider. If you are able to see the slider over here, we can compare the image for 2024 May with the base map, right? So, okay. So this is the basic, very basic use of Google Earth Engine. At least, even if you don't get anything out of today's talk, one thing that you should definitely get out of today's talk is how to visualize the data set. I'll show you one more example. Not only Landsat 8, let's say you want to try Sentinel data. So I'll just click on Sentinel from the data Earth Engine data catalog. Then we have Sentinel-2 present over here. Sentinel-2, we have surface reflectance. Similar to Landsat 8, it also has bands, but this time the bands are known as B1, B2, not as SRB1. This time they're just known as B1, B2. It is something unique to every satellite. Every sensor has their own nomenclature. And then there are again some sample code which is provided over here. I can again The idea of this code is again similar. The idea here is, yes, first of all, we are importing the data set. How are we importing the data set? Sentinel-2 is there. Its unique identifier is Copernicus S2 underscore SR harmonized. This helps us how to import the data. We write EE.image collection. So all these data sets are known as image collection in Google Earth language, Earth Engine language. This image collection is here. We can then filter them into some specific range. If you want to get rid of cloudy images, then we can also filter and remove the cloudy images. So what is being done over here is they have created a filter called cloudy pixel percentage less than 20. So only if the cloudy pixel percentage will be less than 20, LT means less than 20, only those images will be selected. And how do we know about this term called cloudy pixel percentage? We can get to know about this term from, it should be over here somewhere. Image property. Yes, it is an image property. So every Sentinel-2 image, this kind of metadata is provided about in that particular image. What is the percentage of image which is cloudy? So we only want to keep uh, those images which are less than, in which clouds are less than 20% of the area. And then similar to last time, we have the visualization parameters that we are selecting only these bands B4, B3, B2, the same as red, green, and blue, with this min and max boundaries. And map center is same, that where do we want to focus the Google Earth Engine when it runs this code, and it will show up the data set. Okay. You can also run this Sentinel-2 example as well. So I'm running this example. It is opening up somewhere in Vishakhapatnam. Okay, very close to Vishakhapatnam. Again, we can bring it to Gorakhpur. Let me show you how. So I'll just turn off this layer, move to Gorakhpur. Where is Then get the coordinates of Gorakhpur using the inspector. Click on the inspector, click on Gorakhpur, click on copy the longitude and latitude, and put the longitude and latitude over here in map.setCenter and click run. Then in order to compare both the images from Landsat as well as Sentinel, we can also make the dates same. So in the Sentinel case, I had selected 2024 May to 2024 June. Similarly, I can select the same date over here as well. So run over here. So this is the image that we get from Sentinel. I'm just trying to make the latitude, longitude exactly same. Okay, so this is the image that we get from Sentinel, and this is the image that we're getting from Landsat over the same time duration and over the exactly same location. We can see that Sentinel is slightly sharper because it has better resolution, and it also seems to have better radiometric resolution as well. It's as compared to Landsat. So this was very quick example about how to get started with Google Earth Engine. So let's go back to our slide. The surface reflectance and top of atmosphere, as we know, surface reflectance is the light reflected at the surface, and this is what we use for our analysis. Then, apart from the surface reflectance and that analysis, one more thing that you can that you should pay attention when you're getting started with coding is you should notice the color scheme which is presented in Google Earth Engine. You see that some are written in blue, some in purple, some in orange. Things which are in red or orange actually need to be provided by the user. So we need to type those things based on our own requirement. It can be which data we want to use, for example, Sentinel, which date range, or which bands to select. Then things which are in purple are actually the inbuilt commands of Google Earth Engine. For example, filter date or add bands. If you don't know what is the meaning of filter date, what you should do is go to docs, write filter date, and you can get what it means, filter date over here. It says that this is a command to filter a collection by date range. And we need to provide the start and end date, and it will return the subset of that image collection. Similarly, you can learn about add band. And blue are all the numeric values. It can be, for example, longitude, latitude, it can be some other parameters. So now I will show you how to add NDVI. So I think, no, let's open this code. Okay, so before closing a code, you should always click save. You can see save over here. You can click save, and then it will ask you to give it a name. Then you can give it a name, and then it will save the program for you. And you can run this program by clicking run. If you want to share it with someone, you can click get link. Then it will generate a link, and you can share it with someone. Then so in another program that I've prepared, this most of the code is similar to the last one. It is using Landsat 8 images filtered between 2016 and selecting this band. One more new thing is happening in this one. In this one, instead of giving the latitude, longitude, I have created a shapefile over here. So I'll show you how to create a shapefile because this is really important to know, very important basic to know. So can see we have something called geometry import over here. This is geometry import. We can create a new layer. Then we can make a polygon. You can see there are different types of polygon we can select. I can draw a rectangle. I will draw a rectangle around Gorakhpur. This is known as geometry 2. Then I can click on the settings button and rename this as Gorakhpur. Right. So now we have this polygon called Gorakhpur. There are also some other polygon like Bangladesh, which is where the example had originally created for. But we have this Gorakhpur polygon, which I have just created. Okay. Then in this program, I have written my region of interest as Bangladesh, which I can now change it as Gorakhpur. So Gorakhpur now shows up in blue, this purple color. So purple color means that this has already been saved. This is something that Google Earth Engine already knows because as you can see, this is something I defined over here. However, if I write Gorakhpur 123 or some other spelling, this is something that Google Earth Engine does not know, so it will show up as black. Okay, so it shows up as purple. That means Google Earth Engine knows the area that we are discussing. Rest everything is same apart from the calculation of NDVI, which you know is a normalized difference between NIR and red. So I will run this program. If you are rotating on the screen with this red uh, marker, I would request you not to do that. We got some errors. Okay, if you get some error, then it will show up in console. So it says that no band name NIR is available. Okay, let's see why this is happening. No band name. Maybe it is because of the date range, but that should not be a problem. Available bands are Okay, I'm not sure why this is happening. Let me try with the other region of interest. It was Bangladesh. Okay. Red. Okay, okay. It's placed in a wrong location. No, about now. Okay, I've turned off the FCC for now. I'm not sure why it is working. I'll look into it later on. Uh, but I'll show you the example for Gorakhpur now. So when we run this, region of interest is Gorakhpur. And one thing you can notice is as I changed from Bangladesh to Gorakhpur, automatically it was able to switch from Bangladesh to Gorakhpur because it knows which shape file we are working with. And because also in the end we have put map.center object. So whatever is the ROI, this whole map will be centered on top of that. Also, we can control the zoom level from 7 to let's say 12 and run again. So now it's very much on top of Gorakhpur. And we have two images here, NDVI and True Color Composite. So let's look at those images. So we have, this is the True Color Composite. And on top of that, now NDVI is going to load. So as you know, NDVI value varies from -1 to 1. But this is the uh, theoretical range. Actually, it tends to, for forestry, it tends to vary more from 0.0 to 0. Maybe zero point 0.7 or zero point 0.6. So I'll set that as the range 0 to 0.7 and then click apply. And then we can see dense places with dense vegetation much more clearly. Places with dense vegetation appear slightly lighter than other places. So I think this is looks like either railway station or airport. Maybe airport. This looks like airport because it has bitumen surface, so it is very dark. And around the airport looks like a lot of agriculture places. They're slightly lighter. Similarly, over here, it looks like it's a dry water body which is not covered with some vegetation is growing in that water body, so increased over there. So this is one very simple example of how to get started with Google Earth Engine. And so I've already shared these programs in the slide, and I will share the slide itself with Professor Ankur, who can you can ask for these slides for him later on. So let me just quickly walk through into what are the other things that you can expect from the rest of the training. So other things are primarily doing classification, which is supervised or unsupervised classification. So we can collect training data also over here. We can analyze the spectrum of different types of training data. Then we can perform classification using random forest or support vector machine. And results to ChatGPT that you can use. And it's very good that we have this tool also, especially for those who are not very well versed with programming. So I would congratulate you for being with me for so long. And if you have any question, you can mail me or you can also discuss right now if you have time.
Any one of you have, if you have any queries or question related to session, you all can unmute yourself and you can ask the question, please.
Good evening, sir. This side Rishikesh Anand.
Hello, Rishikesh Anji.
Sir, my question is that how can is there any chances for we can if anyone ask about the how much accurate is this result, then how can we answer, sir, this question, sir?
Hmm. See, whenever the question is about how much accurate is this result, you should have some reference data which has definitely much more accuracy compared to what you have. So it can come in the form of ground truth. It can come in the form of some more high resolution image in which you can visually identify the different features, or it can also come in the form of some other technique. For example, let's say we are measuring uh, air pollution from the remote sensing. So accuracy of that air pollution from remote sensing is measured with the help of some sensors which are available from CPCB or from some government side. So accuracy is always about what we are producing with respect to some reference data. And this is how validation is done. For classification, I think this was your uh, dedicated question. So for classification, we can generate classification accuracy metrics. And similar to how we provide the training data, we can also provide the testing data in Google Earth Engine. So from the training data, the classifier will learn the model, it will predict the land cover classes in different regions. Then using the test data, it can be used to generate the fusion metrics.
Thank you,
So,
sir. Thank you, Prakash,
yeah.
sir.
I can see one question from Mr. Santosh Kumar Mandal about, is it possible to get satellite data every month? Not only every month, depending on the satellite, you can also get satellite daily. For example, Sentinel-5 or MODIS or VIIRS, they are available on daily basis. So daily you can get those. Then Landsat and Sentinel-2 we can get once every uh, Landsat we can get once every 16 days, and Sentinel we can get once every 6 or 7 days. So depending on the satellite overpass frequency, that is how we can get the data set.
Any more? Thank you, sir.
Okay, thank you so much.
Thank you once again, sir, on the behalf of organizing team. Once again, from the bottom of my heart, I am so much thankful that you accepted my invitation and your presentation was, very informative. It was a hands-on session, and I guess it will be useful for everyone out here because many of us are from academic background. So once again, thank you. And in future also, I am looking for such more wonderful session from your end, if possible. So once again, Prakhar sir, thank you so much.
Thank you so much. It was great to be here. Thank you.
Okay, sir.